let's work on the maximum index for the local coordinates. Do we have a... Okay, so we don't need a LDX min. We're just using 0. I mean, we could... If we wanted to be explicit and make this not a magic number, we could. I like being explicit, so let's... You know what? Why don't we do that? So, that also means LDX min, right? So we got... Oh, sorry, LDY min. LDY min... LD... Okay. And then we would also need it here as well. So LD x min, and then we can change this 0 to L D y min. And then really quick, we want to make sure that nothing... We want to check our code. So when I'm like clicking things like this, a lot of what I'm doing is checking for complementariness and symmetry within the code. Alright, because there should be some type of visual symmetry based on the way I've written this code, and if there's not, then that tells me that somewhere I've written something incorrectly, right? And the most common thing you're going to do wrong is something like this, where it says it's an X, but it should be a Y. And one of the things we would instantly see here when we're just clicking around, right, is, oh, we notice that this is, oh, why is something down here lighting up, right? Oh, that's wrong. That should be a Y, right? Because we notice that when we click all these, it's just stuff down here. When we click all these, it's all stuff up here. So by just clicking things really quick to just check, really quick to make sure that everything kind of checks out. One of the most common things that I get wrong is, accidentally typing a variable wrong, and finding bugs like that can be quite difficult. I mean, once you get used to knowing what those bugs kind of look like, it'll be easier to find. But between taking more time to write the code or using that time to debug, like if I have to use the time no matter what, I would rather use it writing the code, because the time spent being meticulous like this is much more enjoyable than the time spent debugging code and pulling out your hair. So you're going to have to use that time no matter what. So do you want to spend 3 hours being meticulous? Or do you want to spend 3 hours debugging code and looking for some fucking problem? You know what I want to do? I want to spend those 3 hours just being meticulous and making my code as pristine as possible. That's where I want to spend my 3 hours. And yeah, I mean, that kind of sucks that I'm saying, yeah, no matter what, you're going to have to spend that time, because you're not infallible, you're going to make mistakes, but you do have a little bit of a choice of where you want to spend that time. And I want to spend it here just being OCD and making everything look nice. Okay, so let's get to work on these maximum minimum values, and because we have not defined them yet. So it looks like this is okay. So do we have a variable for the width of a single tile yet in this code? And I don't think we do. And that is the width of a single tile is basically the same thing as LDX min and LDX max, right? The width of a single tile would be LDX max minus LDX min and then plus 1. And we have our local. Oh, this is hold on. So I have screwed something up here, because when I'm talking about LDX is the local coords for the entire viewport, which, so this is definitely the wrong local coordinate that I'm using down here. We need some type of tile local coordinate, which I already kind of like made the variable for that. Like there was the whole thing about that earlier before I got up and left, and I call it like Tico or something like that. So let's, yeah, Tinco, I called it that because that's the, yes, an LDX is used in that calculation. And what other variables am I going to need here? TX, TP0 width, TP0 height, and that's the size of our tile variable. So the number of sections X, the number of sections Y. Number of sections is also synonymous with the viewport 1 width and height. So what we can do is I'm going to change around this formula. Actually, you know, I'm just going to cut a whole bunch of this and rework it a little bit. And divided by nx, let's see, nx equals, did I not take enough of that? No, okay. So we know that nx really just, right, these are equivalent. So anywhere we see these two colors, we can swap the variables, right, where there's the matching colors. And what I'd like to do is, we already have VP1 width in our main code. So let's take a look at our code here, and I'm assuming we do have that defined, but let's just double check. Yeah, so we have that defined already. And we might just want to make our note here that nx equals VP1 width, and then ny equals VP1 height. So I don't want synonymous variables running around my code, because that would make it harder to find the connections when I like double-click things. But I can make a note that, you know, nx is equal to this. So n number of sections, right? And so we can just make a little note there that the number of sections that you can divide the destination viewport into is the same thing as the width and the height of the source viewport. And that's because the source viewport, 1 pixel on the source viewport, is equivalent to a single tile, right? Because each pixel on the source viewport, each pixel on the source viewport, VP1, is encoding a tile. Now, if that somehow changed, right, and maybe like a cluster of 4 pixels on the source viewport, VP1, if a cluster of 4 pixels was the data used to create 1 tile on the destination, then this statement here, nx equals VP1 width, that would no longer be true. And so we could make a little note there that this equality is only true if 1 pixel on the source viewport VP1, or rec VP1, is used to encode a tile value. If, or For example, if a cluster of 4 pixels were used to encode a tile value, then nx not equal to vp1 width and y not equal to vp1 height. So just a little note of why they're equivalent. I don't see any reason to be using this nx and ny variable yet, because I don't plan on changing the equivalence, but that does give me a thought of, like, maybe I should. I don't know. I have to think about that. Well, let's look at some of our other code here. So this nx, ny. Well, I mean, we already have the formula here, so, you know, maybe why not? So our formula is for calculating nx. We've got 2 versions here. Number of sections. Okay, so you know what? I'm gonna, I think I am gonna use nx, and I'm gonna add a little bit more code just to make it a little bit easier to refactor if we have to, like, revisit this. I don't think I'm ever gonna do this, but let's go over here, and we're gonna notice that, you know, here's the same formula here and here, and that's why they are equivalent. Divided by, that could just create a whole bunch of weird problems. Sure, we'll just, pixels per tile x, and, sure, why not? We'll just, so, by pixels per tile y. Pixels per tile. No, that's a little bit hard to read. It's more like, source encoding it would be like src encoding cluster x and source encoding cluster y and values that we never actually want to change. But then we could just say var, and we could put these here, and we just set them to 1, right? So we're just saying that it's a 1-to-1 mapping from a pixel to a tile. And then if it was a cluster of 4 pixels, then this would be 2 and 2. So then you'd have a cluster, a 2x2 cluster of pixels in the source that would be used to encode a single tile on the destination. But maybe we do want to just have this here to kind of self-document in case we ever decide to change that. I don't think we will, but understanding why nx and ny are equal to vp1 width and vp1 height might be useful to know. So we have so let's just make a little section here, and I don't know what to call it. So oh no, I'm just gonna gonna say v and n. Right, so I'm just gonna make a section here to kind of let me know that all this crap right here is kind of related. Right, so this over here. And then VN, what does VN stand for? VN is viewport, viewport 1, width/high, and n underscore x y chords. No, they're not chords, values. I don't know. So obviously that's convoluted. But anyway, so we have a little, we just sectioned that off so we kind of know what that's all about. And we can identify this as being, you know, a single related thought. Tile encoding. Tile encoding X. Tile encoding, and it's more like a scheme. Or tile encoding, grouping. I don't know, or maybe scheme would be more general. Then change that to a Y. And I'm just going to make a note that I'm going to have to put using my shortcut script, but I won't do that right now on camera because it's been tedious, and maybe I'll spare you that. Okay, so we have NX and NY, and we thought about, you know, how we actually want to use them. And do I need this open? Because I keep on flipping to it, and I think I'm pretty much done with this. So let's close that and stop looking at it. So our formulas for calculating the tile X, tile Y, aka source X and source Y. We don't need that anymore. Let's close that. Here's my little scratch pad here, which, oh, here's the size of the tile that you're going to use. So let's take that right now and go back into our main code and figure out where does that belong. Obviously, it belongs after the NX, NY calculation. Yeah, because that's the number of sections, so that belongs on the outside, but this belongs on the inside of the loop. It does use LDX and LDY, right? No, because that's me screwing that up again. I think we need to put this down here somewhere, and then I remember that these variables are not correct. So size of a single tile. Well, hold on. Number of sections. Okay, this does not belong. Yeah, the size of a single tile is not going to change over one, like, render pass. So that would actually go down here, right? Yeah, because NX and NY is not changing. Neither are these widths, at least not for, like, one draw call, right? So that goes here, right? So this is tile pixels, viewport 0, and the width. So the tile pixels is in the number of pixels within the tile. So you can make a little note. Tile pixels, and this is DST for destination, or you can actually write it dest, aka 0. 0 is the destination viewport. Okay, so now that we have that, we know that this is part of the formula for figuring out what tile we're in. So we can go back over to, let's take this stuff here, let's just close that. Go back into the calculations we were kind of whittling, tweaking. Okay, yeah, so we have the tile X, tile Y, which we've already made this calculation. This is just a more condensed calculation. So we had the used up pixels, and then we were thinking that we weren't actually going to use these variables and that we're just going to inline these and then make a note that these are the used up pixels. And this is our local coordinates. So let's take that. This is what we need. So let's put that calculation. Where do we want to put that? Well, here's where we're kind of like figuring out that border stuff. So this is kind of where we wanted these values. So we can put them in here. And then we need to... Whew, we're going to run out of room again. Okay, we'll worry about the column limit that I just went over here, right? I just pasted this right here. Let's worry about that later. But this thing that I'm calling LDX min, LDX max, that is a bad name because it should actually be like the min and the max for these variables here. So we need to fix that, and then I also want to like make a note in my shortcuts that these LDX min and LDX max are probably not variables that I want to be using, where it's like me typing these variables in the future is likely indicative of me not knowing what the hell I'm doing, because this is wrong. We shouldn't be looking at LDX because this is the entire viewport's coordinates, but we want to look at the local coordinates that are the local of the pixel within the tile, and that's what these are, right? These are the local pixel coordinates. So I will fix that, and I'll make some notes, and then I'll restart the stream and restart the video because I just went over my 20-minute time limit. So yeah.